Hello, could you please confirm once that you can see me, you can hear me, as well as you can see the presentation?
Hello, can you repeat, sir?
Could you please confirm once that you can see me, you can hear me, as well as you can see the presentation?
Yeah, it's audible and I can see what you are presenting.
Okay, okay. Thank you so much. Okay, okay, let's start. Good afternoon, everyone. My name is Ambuj. I am a research scholar at Agricultural and Food Engineering Department, IIT Kharagpur, and I'll be taking your live interactive session on the course Farm Machinery. This course is taught by Professor V.K. Tiwari, Director, IIT Kharagpur. And what we will be doing in this particular session, that I'll be posting some of the objective type questions based on the previous week's content in front of you, and you have to answer those questions using the chat box. Okay, you have to just type in the correct option based on the based on your knowledge and understanding, and then we will look the question in great detail. Okay, so the very first question for the day is: the application rate of an ultra low volume sprayer varies in the range of 5 and 10 liters per hectare, less than 5 liters per hectare, 10 and 400 liters per hectare, or is it less than 100 liters per hectare? Okay, just try to give the answer to this particular question, okay, based on your knowledge. Then we'll discuss.
Sir, I think the correct answer is B, less than 5 liter per hectare.
Okay, okay, okay. I'll just type in here B less than 5 liters per hectare. Liters per hectare. Okay. Yes, indeed, you are correct. Okay. The application rate of an ultra low volume sprayer varies in the range of less than 5 liters per hectare. Yes, indeed, it is correct. Okay. See here, let us look at different types of spraying patterns. Okay. Ultra low volume, what is the definition? Ultra low volume application refers to spraying pesticides at a very low volume. Okay. We are only targeting the areas which are infested by the pests. Okay, that is why the name here has been given as ultra low volume spraying. Okay, key characteristic is minimizing the amount of liquid used while achieving the adequate pest control. Okay, pest control, for pest control, this particular method is generally used. Okay, ultra low volume spraying. Okay, I'll just show you the nozzle as well as the uh, other components in great detail, as well as I will show you an autonomous, semi-autonomous ultra low volume sprayer, unmanned. Okay, pesticides. Okay, just for achieving the adequate pest control. Okay, typical application rate varies between 0.25 to liters per hectare to 5 liters per hectare. Okay, this is the in general application rate. Okay, it is not fixed, but it is always less than 5 liters per hectare. This thing you have to keep in mind. Okay, other options were 5 to 10 liters per hectare. Okay, it's on very high end for ultra low volume applications because the nozzle is designed to handle that much volume only, up to 5 liters. Okay, per hectare. That is the specific application rate. Okay, discharge rate is designed for ultra low volume spraying only. Okay, so we cannot go for more than that. Okay, then 10 to 400 liters per hectare. This is done in conventional spraying methods using knapsack sprayer, okay, or tractor operated sprayers. Okay, and less than 100 liters per hectare. Yeah, this is also a very wide range, less than 100 liters per hectare, but the specific range is less than 5 liters per hectare. Please do keep this in mind. Moving forward, see here, if you can see this particular figure which I have shown you, I'll just zoom in. Yes, this is a robotic platform for smart weed management. This is typical ultra low volume sprayer. Okay, this is unmanned. I'll tell you each and every component in great detail. I think you would be able to see here. The very first component in the bottom, I'm showing here, boom with 3 spray nozzles. Okay, so here, as you can see, 3 different nozzles are there. Okay, 1, 2, and 3. Just mark in for you. Just a second. Just a second. Okay. See here, 3 different nozzles are there. Okay. This one, first one. What is happening? Yeah. First one, then second one, then third one. Okay. This is very site specific application of the pesticide. Okay. What is happening here? See here, some specific nozzle is there and a camera unit is there that has been placed. Okay. RGB FLIR camera you can see here. Then it is connected with 12 water pump, 12-volt pump. Okay, 12-volt water pump. Directly it can operate using the battery. Inverter has been placed to charge the battery. Okay, 2 batteries they have provided. Then a 25-gallon tank they have provided, and then main processing unit and display. See here, this particular components which you are seeing here, this is Jetson Orion NX. Okay, this is the most advanced microprocessor which is available in today's scenario in the market. Okay, and they have connected this particular uh, uh, microprocessor with the LCD display, touch LCD display. Okay, so here they are using this particular platform. Okay, Ubuntu platform. Okay, for Ubuntu is the operating system for operating this particular unmanned sprayer. Okay, and here you can see these DC gear motors they have provided on both the sides. Okay, why going for DC gear motors? Because they are very high torque motors, and in case of agricultural environments, high torque is the major requirement. Okay, because the sprayer should not get stuck anywhere. Okay, this is the thing here. And when this RGB FLIR camera which they have provided, that will detect particular infestation, then only these nozzles will get activated. Okay, and then only the spraying would be started at the site specific location only. Okay, this particular one at the right hand side which you can see, DC motor controller. What happens when we try to connect this through the we have to operate a DC motor. Okay, so DC motor would be having some specific current and voltage requirements. They have to be automatically controlled with respect to the speed which we have provided as an input. Okay, so what happens, as we have provided the input as the speed, so the current and voltage, that adjustment is done by DC motor controller. Okay, so directly if you will connect a DC motor to a battery, that will only give you a specific RPM as well as a specific forward speed. Okay, if you have to vary the torque, if you have to increase the torque and decrease the speed, then you have to go for DC motor controller. That is just like a governor in a tractor. uh, okay, in a tractor, governor is there which controls the fuel supply, okay, to the engine, as well as transmission system is there, gearbox is there. So same, both the functionings have been replaced in case of a DC motor with DC motor controller. And they have provided 12-volt battery, and that particular sprayer is controlled by RC control. So we can say it is an unmanned sprayer. Okay, there are levels of autonomy. You have to understand this. Autonomy is not a single term. Okay, autonomy is a used term. What happens, that if a vehicle you are designing that is fully autonomous, means it has the capability to judge uh, everything on its own, then it is said to be fully autonomous. Okay, here we are using it as an RC control device, remote control device. So it is not fully autonomous, it is just unmanned. The main machine is can be operated without any human interference, but the guidance part we are providing using the RC control system. Okay, remote control system works on the principle of infrared waves. Okay, please do keep in mind, either using infrared waves or using Bluetooth. Okay, two possibilities are there and different channels are there. In this particular frame, whatever the RC remote control you are seeing, that is based on radio waves. Okay, so different channels are there, different types of controllers are there. Okay, remote controlling is which you see in your television, or which you see in your AC, that is infrared control. Okay, while connecting any device, okay, with our phones, we are using Bluetooth. Okay, so Bluetooth remote control, it is generally found in Android or iOS devices, using mobile devices. And here in this particular remote control which you are seeing, that is controlled using radio waves. So different channels are there. When you will press a certain command, okay, that will initiate a particular channel fragmentation. Okay, that will lead to a certain actuation in the device or in the machine. That is the thing. Okay, these were the different parts, different nozzles, different, I think, main processing unit and everything regarding to the unmanned sprayer. Okay, if you are having any doubt, then please do ask me at any point of time. Okay, yes, I hope it is clear. Let's just move forward. Okay, if you have any doubt at any point of time, please do ask me repeatedly. I am saying you. Okay, don't hesitate. Yes. Next question, which type of spray nozzle is generally used for spot application? Okay, spot application. This is a keyword of herbicides. Hollow cone nozzle, solid cone nozzle, flat fan nozzle, or rotary nozzle. If you know the spray pattern type of all the nozzles, then you can very easily say which type of uh, nozzle should be used for spot application. Try to answer.
The correct answer should be B, solid
Yes,
cone
yes,
nozzle.
yes. Yes, yes, yes. I'll just type in. Your answer is B, solid cone nozzle. Okay. Yes, indeed, it is the correct option. Okay. The type of spray nozzle which is generally used for spot application of herbicides is solid cone nozzle. Okay, different types of nozzles have been given here. Okay, see, try to see this in great detail. Okay, for spot application of herbicides, type of spray nozzle which is being used is solid cone nozzle. Solid cone nozzle are preferred for spot applications. They are compact. They have a circular spray pattern that is effective for targeting specific areas or weeds without excessive spray drift. Okay, spray drift is generally minimized here. That is why we are, for spot application of herbicides, we are using solid cone nozzle. Okay, spray drift happens due to wind speed. Okay, as well as the movement of the vehicle while the spray is happening. Okay, so for maximum utilization of our resource, that is pesticide here, we generally go for spot, for solid cone nozzle. Okay, hollow cone nozzle is there. Okay, hollow cone nozzle produces a ring shaped spray pattern. Please do keep this in mind. It produces a ring shaped spray pattern. Highest concentration of droplets is around the perimeter of the circle. As the name, so is the function. Okay, hollow cone nozzle. Just like a hollow circle, which is having an outer diameter as well as an inner diameter, but is hollow from inside. That would be the spray pattern of this hollow cone nozzle. Okay. Commonly used in applications where uniform coverage around a target area is needed. Okay, such as pesticide or fungicide applications, where good coverage on plant surfaces is essential. Okay, that in those particular cases we are going for hollow cone nozzle. Rather, other than that, another option was there, which was flat fan nozzle. Okay, flat fan nozzles produce a flat fan shaped. Okay, fan shaped in the shape of a rectangle. Flat fan shaped spray pattern with droplets distributed evenly along the width of the fan. Okay. Nozzles are versatile and widely used in agricultural spraying for broad coverage of crops or areas. Usage is same only, delivering the herbicide, insecticide, fungicide, okay, to large target surfaces. Okay, the surfaces are generally large, the coverage area is large. That is why we are going for flat fan nozzle. Okay, functionality is same, but based on the requirement, we are selecting which type of nozzle we have to choose. Other option was rotary nozzle. Okay, rotary nozzles are produce a spinning circular type of pattern. Okay, rotary nozzles, they generally produce a spinning circular spray pattern. Okay, which can vary in coverage depending on the design. Okay, often used in applications where a uniform spray pattern is needed over a larger area. Okay, if particularly larger area has to be covered, like in an irrigation system or in a specialty requiring controlled or adjustable coverage, then in those particular cases we are going for rotary nozzles. Okay, all different types of nozzles are there along with the application. Please do keep those in mind. Okay, in which particular case you have to use which particular type of nozzle, the exact nozzle, how it looks, how the spray pattern is there, we will be just seeing in few upcoming slides. Okay, yes, here I have shown you the spray pattern as well as the type of the nozzle as well as the opening of the nozzle. Okay, see here, try to see the flat fan nozzle. Okay, it will be spraying and the angle of spraying would be 65-degree. Okay, it is just like a full cone. Okay, the tip of the nozzle will look like a full cone. Okay, at the end you can see. Then hollow cone nozzle is there. The spray angle would be somewhat 80-degree. It would be spread, but at the base, okay, the spray pattern which you will see, there would be a large circle which would be left. Okay, so it would be having an outer diameter, it would be having an inner diameter. Okay, but the hollowness would be remaining. Okay, then you can see full cone nozzle is there. The spray would be just like a cone. Okay, complete coverage is there. In case of a flat fan, it is somewhat ellipsoidal. Okay, it is just like an ellipse. Two major, the spray pattern I am talking about, it is just having a major axis as well as a minor axis. But in case of a full cone, it would be some perfectly circular. Okay, flat fan nozzle looks like this. The tip of the nozzle you can see. Okay, moving forward, which is the whole guideline, in which case you have to use which type of nozzle, how it would be looking, and what would be the spray pattern as well as the spray angle. Spray angle would be generally given in the question. Okay, you don't have to worry about that, but the application rate, in which case I'll be using which type of nozzle, you can keep in mind as a handy guideline. Okay, for you people. See here, extended range flat fan is there, then standard flat fan, then drift guard flat fan. These different types, specific types are there available in the market. I have shown you which type would be there for which application, right? For example, for drift guard flat fan, it would be very good for herbicide application, good for fungicide, good for insecticide. Okay. And in case you want to go for an extended application rate in cases where your crop is more infested, okay, the infestation has spread a large amount of time, a large amount, okay, in a large amount, then you can go for twin flat fan. Okay, the application rate would be twice. In one stream only, the breakage is there between two different streams. Okay, so the first pass would be there, then second pass would also be there. This is the thing. Okay, here you can see two different spray patterns are there. Okay, then turbo flood wide angle, then wide angle full cone, then flood nozzle, then raindrop hollow cone nozzle. Okay, different types of nozzles are there based on the application rate and which type of spray pattern you want to see, and what is the level of infestation in your crop. You can always go for the nozzle type. Okay, extended to that, I think, yeah, this image got pasted, I think, twice. Same thing is there. Okay, just ignore it. Moving forward, yeah, this is another question. Okay, next question for the day. If you at any point of time, if you are having any doubt, then please do ask me. Okay, the rest we are moving forward. In chemical spraying system, mechanical agitation is normally preferred over hydraulic agitation for pressures above 100 psi, 200 psi, 300 psi, or 400 psi. What is the opinion? Yes. Any opinions? Yes. Any opinions?
C.
Okay, 300 psi. Okay, good. I'll just write it down. 300 psi from
Hello, am I
yes,
audible?
yes, yes. You are audible. I heard you. You said C. 300 psi. Okay, just wrote it down. Yes, the other person who has joined, Uday Kumar S. Will he like to give his opinion about this question? You just don't have to be correct at the very first attempt. I just wanted that you should participate. Okay. If you have any opinion, then please do tell me. Okay. Three 30 pp. Okay, I think you meant 300. Okay, okay. Good, good. Very good. 300 psi. Yes, very good. Yes, Varnika has also joined. Okay. I'll wait for her 2 minutes more. Let her answer also. In chemical spraying system, mechanical agitation is normally preferred over hydraulic agitation for pressures above 100 psi, 200 psi, 300 psi, or 400 psi. Okay, this is the question. Please do answer, Varnika. Okay, see, yes. Great. Indeed, you all are correct. It is 300 psi only. Okay. The mechanical agitation system, different types of mechanical agitators are there. They have been taught in theory in great detail. Okay, what is the design, how you have to calculate the velocity, which diameter of fins you have to keep. Okay, mechanical agitation means uh, you will be using an agitator. Agitator is a tool. Okay, just like a small ball is there in case of your protein shake agitator. Okay, your protein shaker. Okay, in that case a small ball is there. That is an example of mechanical agitation. Okay, where you have to just mechanically agitate, okay, the mixture in order to make a uniform mixture, okay, or uniform solution. In that case we go for mechanical agitation. For making a uniform solution we go for mechanical agitation. Means you have to use a mechanical agitator. That would be a device which we use to mix the contents of the mixture. That is the meaning here. Mechanical agitation is typically preferred over hydraulic agitation in chemical spraying for pressures above 300 psi. And what is 1 psi? 1 psi is equal to 6894.76 pascal or 6.8 kilopascal. If you don't want to remember the entire thing, please remember it in short. So in numericals, you can go for quick conversion. 1 psi, pounds per square inch. 1 pound is equal to 0.454 kilowatt for 0.454 kg. Okay, that is equivalent of 1 pound per square inch. Inch square, 1 inch, 2.54 centimeters. Okay, so these are the units. 1 pound per square inch is equal to 6.89 kilopascal. That is the conversion. Please do try to remember it. At pressures above 300 psi, mechanical agitation is more effective in keeping the chemical solutions well mixed, preventing settling or the separation of the ingredients. Separation can also take place. Okay, if your mixture is not properly mixed, then the separation of the various components might also take place, which we want to avoid. That is why we are going for mechanical agitation. Hydraulic agitation, yes, it is definitely used by going for an air pump. Okay, if the agitation has to continue for more than a time period, like say for 2 hours, okay, then we go for mechanical agitation because the mixture is getting continuously mixed. The chances of separation of the solvents is less in case of mechanical agitation. Okay, this you keep in mind. Hydraulic agitation may struggle to maintain uniform mixing at higher pressures. Due to limitations in pump capacity and efficiency, the efficiency is limited. But hydraulic agitation can be used in case the spray duration is less. Okay. In that case, you can go for hydraulic agitation. But in cases where the mixture has to be agitated for a long period of time, you have to go for mechanical agitation only. Okay. Mechanical agitation often chosen for reliability and effectiveness in high pressure spraying applications. The pressure has, if it is maintained at a higher in a higher range, then you can generally go for mechanical agitation. This is the thing here. Okay. Please, if you any of you are having any doubts, then please do ask me. Okay, I am moving forward. Okay. As per the BIS standards, next question, fourth question for the day. For routine and acceptance check, the sprayer or pump shall be run for a minimum period of 25 hours, 100 hours, 75 hours, or 48 hours. That has been mentioned in the BIS code. I have taken the question directly from the BIS code only. Okay. Please do try to answer this particular question. Yes, nearly 50 hours or 48 hours should be correct. Yes, exactly. 48 hours should be correct. Okay. Maybe, may not be. Let others answer, then I'll tell you the correct option. Okay. Yes. Yes. What are the opinions of other two people who have joined? Please do tell me. No need to get afraid. Okay. Maybe you are not correct in the first attempt, but please try to give your opinion at least. Okay. What do you feel? What should be the correct option? Okay. Please do try to give it. Okay, I think you are not getting. Okay, no problem. I'll tell you the correct option. It is the 48 hours. Okay, indeed. This is the particular code I'll show you where it has been written. Okay, this is the code IS 10134 This is the BIS code for testing manually operated sprayers. Okay, so what is the scope? In which case, in which particular sprayers you can use this particular code? In case of compression knapsack sprayers, okay, then your knapsack, normal knapsack sprayer, or your foot sprayer, or in case of your rocker sprayer, stirrup type sprayer, okay, agitation sprayer, or atomizer type sprayer, depends on the nozzle. In all the cases, you can go for testing the sprayer using this particular code. Okay, then sampling has been given. Then how you can just pick a sample from the entire unit, okay, which is coming from a factory, then running in, okay, then test which particular test you have to perform, okay, then visual examination. First you will visually examine how is the quality of the sprayer, how is the build quality, what is the quality of the material, then going for checking of dimensions, then checking the material of construction, then performing the tests. First test is discharge rate. Okay. First you have to measure that. Okay. Going for it, the entire procedure has been given what has to be the exact amount of cranking, how the liquid has to be collected, okay, how it has to be measured, okay, which pressure you should operate. Everything has been given. Similarly, going for foot and rocker sprayer, the entire thing has been given. For knapsack piston type operated sprayer, the entire thing has been given. Okay, how you have to calculate the discharge rate. Similarly, for atomizer sprayer. Okay, then the next part. First, we have calculated what is the discharge rate using the entire procedure that has been given here. Okay, then you go for testing the volumetric efficiency. Okay, volumetric efficiency has to be calculated for different types of spray using the procedure that has been given here. I'll tell you in brief what is the exact procedure. You have to just measure the discharge rate for the particular amount of piston displacement or the particular time amount of strokes. That is the thing here. That will give you the volumetric efficiency. Entire procedure has been given as well as the format also has been given at the last. Okay, try to read it after the class is over. Then go for pressure development. Okay, testing for leakage. Then what is the throw? What is the reach of the spray that you can measure? Then spray coverage you can measure, okay, using the procedure that has been given. Okay, I in our field, in our cases, when we try to develop a sprayer, we use a spray patternator, okay, for judging the quantity, for calculating the quantity as well as the pattern of the spray nozzle. We use go for the spray patternator. Okay, then test for component, different components are there. Pneumatic test is there, hydraulic test is there, then hose, what is the hose connection is there. Okay, strap and this assembly, how you can go for it. Okay, everything has been given here. And the thing which I have asked, okay, that is also here. Test for endurance. Okay, before it we go for test for gasket. Okay, different components you have to check, okay, whether they are in the manner which has been mentioned in the code. After that, only as an design engineer you can say that the sprayer that has been developed or which is coming in out of a factory, it is up to the mark. Okay, it is to the standard where it can be subsidized. Okay, that you can only say after it follows the certain criterion that has been mentioned in this particular BIS code. Okay, then test for valve assembly is there. Okay, the entire valve assembly you have to bring it out and you have to check. Then tank skirt component, okay, impact that you can check. Okay, the procedure already has been mentioned. Then fatigue And the thing which I have asked you is test for endurance. Okay, here it has been mentioned. Then for routine and acceptance check, sprayer or the pump shall run for a minimum period of 5 minutes instead of 48 hours. Okay, routine and acceptance check. But for detailed check, okay, for the detailing, okay, you always have to go for 48 hours. See here in these lines, it has been mentioned. I'll just read it out. The sprayer or pump shall be operated in accordance with the method given in respective discharge rate test. See the section 6.1. Minimum period is 48 hours without measuring the liquid. Okay. Period should be covered minimum with continuous stretches of 6 hours. In 6 hours duration, you have to go for 8 durations. Okay. That will give you amount to the total stipulated time, that is 48 hours. Okay. That you can go for it. Yes. This was the code, and at the end, the entire test apparatus for determination of fatigue and failure in compression, failure and shear, everything has been provided in this particular code. The code number, at least you can remember, BIES code is there 10134 to 1994 for testing the manually operated sprayer. Okay, I have provided the code here also so that you can revise the entire thing in one go. Okay. Yes, let us move forward. If at any point of time you are having any doubt, then please do ask me. Okay, I am moving forward. Yes. Which of the following is not a positive displacement pump? Diaphragm pump, piston pump, centrifugal pump, or rotary pump? Okay, try to answer it. It's an easy question. Okay.
Uh, C. Centrifugal pump.
Okay, okay, good. Good. I'll just write it down. C, centrifugal pump. Yes, the other people can also answer. Those who have joined. Yes, C. Very good. I can understand the previous one was a bit difficult, but this one is easy. Please do try to answer. Uday Kumar, yes, C. Very good. Very nice. Yes, indeed, the answer is centrifugal pump. Okay, I'll just tell you. See here, the pumps which are having a fixed volume of fluid within the each cycle, they are said to be of positive displacement. But in those pumps which are not having a fixed volume, or the volume varies within each cycle, okay, the volume is increasing, decreasing with respect to the speed of the operation of the pump, they are said to be non-positive displacement pumps. Okay, it is not negative displacement pump. Okay, don't get confused. Positive opposite of positive is negative, so don't say it is negative displacement pump, because it is also pumping fluid. But in case of a positive displacement pump, the volume of the fluid within the each cycle would be constant. Okay, fixed volume would be there. But in case of non-positive displacement pumps like your centrifugal pump, the volume of the fluid within each cycle would not be fixed. Okay, this is the thing. Diaphragm pump, yes, it uses a flexible diaphragm to displace the liquid. It creates suction and discharge phases to move the liquid. Okay. Then piston pump is there. It uses a reciprocating piston to displace the fluid, which is typically driven by an engine or a motor. Rotary pump is there. Yes, Uday Kumar wants to ask something. If at any point of time you want to ask something, please do ask me. Okay, no problem. Yes. Then rotary pump is there. Rotary pump is operated by a rotating mechanism. You can you can see it in your lab. Okay, hydraulic pump laboratory would be there in which you would be shown different types of pumps. Okay. Then centrifugal pump. Okay, it uses an impeller to push the fluid. Okay, so it uses a centrifugal force to move the fluids through the pump. Okay, it relies on an impeller to accelerate the fluid. As the fluid would be moving, it would be accelerated during the entire traversal period. That is the basic principle of a centrifugal pump. It is a non-positive type displacement pump. Okay, so that correct option would be C. All of you have given it correct, solved it correctly. Okay, let us move forward. The flow rate in case of a piston pump, it varies in a sprayer. Okay, what is the flow rate of piston pump in a sprayer? Ranges from 19 to 114 liters per minute, 19 to 23 liters per minute, 75 to 225 liters per minute, or 206 to 275 liters per minute. The flow rate of piston pump in a sprayer. Okay. The previous question, it was an option. Now I have asked the flow rate of the piston pump. Okay. C, good. 75 to 225 liters per minute. Okay, good. A, good. 19 to 114 liters per minute. Okay, that can also be a possibility. Piston pump. Okay, the force would be created using a piston. Okay, so generally it would be in somewhat the discharge rate that has been given. Okay, flow rate or the discharge rate that would be somewhat higher as per basic understanding. The exact range also I'll tell you. Okay. Okay. Let me show you the correct option. It is C. Okay. 75 to 225 liters per minute. Okay. Flow rate of a piston pump. Okay. What happened? I think the slide got stuck. Yeah. Yes. The flow rate of a piston pump in a sprayer can vary depending on several factors like the pump size is there, operating pressure is there, design is there. Okay. Typical range for a sprayer application falls within 75 to 225 liters per minute. Okay. Piston pump delivers the whole range of flow rates depending on the configuration. And for sprayer applications, they fall within this range. Okay. Other options are too bit low or too bit or a bit high. Okay. Please do remember the exact range also you remember, or for your information, the piston pump. Okay. That would be throwing the water. Okay. The forcing the water through a narrow orifice using a piston. Okay. So that is why the flow rate would be much larger. Okay, it wouldn't be so much large that in for the as given in the D option, but it would be between the ranges 75 to 225 liters per minute. Okay, that is the correct range. Let's move forward. Okay, not much was there here to discuss. Okay, the relationship between the volume mean diameter and orifice diameter of a nozzle is given as Please do try to answer it. Okay. I'll tell you it in great detail because two or three numericals are also there. They are based on this particular relationship only. Okay. So please do try to recall what is the exact relationship. Okay. Between volume, mean diameter, and the orifice diameter. Okay. Of a nozzle.
Sir, I think B will be correct answer. VMD is directly proportional
Okay. Okay. Okay.
to its diameter to the power 2 by.
Okay. Okay. I'll just write it down. VMD directly proportional to that I cannot write here in the chat box. I'll just write option B. Pradeep. Okay. Yes, other people whomsoever have joined, please do try to answer it. Okay. It's an easy question if you know the relationship. Okay. Otherwise, please tell me. I'll tell you the relationship. No problem. Okay. Uday Kumar says B. Great. Very good. Okay. B. Great. All the people have said it B. Indeed, you all are correct. Okay. It is directly proportional to diameter to the power 2 by 3. Volume mean diameter. Volume mean diameter is the mean diameter of our spray droplets. Okay. That diameter is directly proportional to d to the power t by 2 by 3, and d here refers to the orifice diameter of the nozzle. Okay. So please do keep it in mind. Volume mean diameter is the mean volume diameter of the spray droplet, and that is proportional to the power d to the power 2 by 3. Yes, it is the correct relationship. In fact, this is the exact relationship. Please, if you are having a notebook, please do make a note of it. Okay. dm is the median size of the droplet, that is directly proportional to d to the power 2 by 3. Okay, d to the power 2 by 3, d capital D is the diameter of the orifice, and p to the power 1 by 3, where p is the pressure of the water flow. Okay, this relationship you can prove also. Okay, uh, but empirically also it has been derived. Okay, we can prove here or also using lot of relationships, but please make a note of this relationship. The exact relationship is this one. Dm is the median droplet. Okay, that is directly proportional to d to the power capital D to the power 2 by 3, and inversely proportional to p to the power 1 by 3. Okay, so for two different nozzles, what would be the relationship? If I want to compare the median diameter of two particular droplets, that would be dm1 divided by dm2 equal to p2 by p1 to the power 1 by 3, as the relationship between the median droplet and pressure is inverse. Okay, so accordingly you can calculate for pressure, and accordingly you can calculate for diameter of the nozzle. Okay, I hope you have understood this point. Okay, yes, this is the explanation. Okay, explanation already I have given you, and the relationship that has been calculated empirically says it that VMD is directly proportional to d to the power 2 by 3. Okay, not much to explain here. Just for your information, why other options are incorrect. Okay, can just try to read it. Yes, if you have understood everything, okay, now, then please do try to solve this particular numerical. A spraying system equipped with a piston pump is used to spray the fungicides in a lychee orchard. Pump has a flow rate of 40 liters per minute. Pressure is given 660 kPa. Mechanical efficiency is 85%. What is the power requirement? Okay. See here, I'll just tell you. The formula also I'll give you. You just have to calculate. Power requirement is given by Q. Q is the discharge rate. Rho is the pressure divided by eta. Eta is the efficiency. Eta here is operational efficiency. It is the multiplication of two efficiencies. First one is mechanical efficiency, other one is hydraulic efficiency. Or if you are given volumetric efficiency, all the efficiencies you can multiply and then you can say it operational efficiency. Okay. So the unit also I'll tell you. See here, power. Okay, it would be SI unit watt. Okay, or Newton meters per second. So Q would be in meter cube per second. I'll just write it down. Just a second. Yes. Q unit is meter cubes per second. Rho unit is rho is pressure, Newton per meter square. Eta is dimensionless, so entire unit would be Newton meters per second. So everything would be in SI unit. Okay. Please try to keep it Newton per meter square. That would be the unit of pressure. So we'll go for 660 into 10 raised to power 3 pascals. 1 pascal is 1 Newton per meter square. Okay. SI unit will go. Then meter cube per second would be the unit 40 liters per minute. Try to convert it in meter cube per second. Multiply both, divide by 0.85. Directly you will get the power requirement. Okay. Just check for it. Okay, approximate answer you can give it in the options. Okay, which option would be correct? Take your time. I'll give you 5 full minutes. Okay, you just try to solve this question. Okay, Varnika is saying D. Very good. She has solved. I'll give you time. Okay, 2 3 minutes more time. Please do try to solve it. Keep everything in SI unit. You will get the answer. Okay, there is no problem in getting the answer. I think Varnika has solved. That is why she has got the answer. Good, very good. These type of questions are common in the examination. That is why, as a practice, I am giving it to you. Okay, it's easy question, and the logic also I have told you. The formula also I have told you. Just try to solve. Yes, 0.518, okay, or 0.52 option D. Great. Very good. Pradeep has also solved. Yes, indeed. The correct option would be 0.52 only. Okay. Both of you have solved it correctly. Okay. Good. Very good. Let us look at the entire procedure. Here I have already told you everything, but for your information, I have solved it in stepwise manner. See here, first of all, the thing was Q. Discharge rate has been given 40 liters per minute. Converting it, dividing it by 60, 0.67 liters per second. And as you know, 1 liter is 10 power minus 3 meter cube. Okay. So accordingly, I'll get the discharge rate as 0.0067 meter cube per second. Okay. This is the thing. Flow rate of the pump. Okay. This was here. Yes. Then pressure 660 kPa. So 660 into 10 raised to power 3 pascals. Then mechanical efficiency 0.85. Okay, everything has been converted to SI units now. Now using the formula PQ divided by eta. Eta is the efficiency. I already told you. Eta is the operational efficiency, which is the sum of, which is the multiplication of mechanical, hydraulic, and volumetric efficiency. Okay. Yes. So directly I'll put the values 0.00067 into 660 into 10 raised to power 3 point divided by 0.85, and I'll get it as 515.29 or 0.52 kilowatt. What are the values you are getting? That would be 100% correct. Okay. These are the approximate values. Okay. For your reference, I have just given the entire thing here. Okay. Similarly, if you don't want to the complicated procedure, directly you can go with the formula also. That approach also is given here. QP divided by 60,000 into E time, and whatever the units are there, please do check in mind. But I, rather than going for it, I always advise you to go for SI units, because you will never get confused and you will never commit a mistake in the examination. Okay. That is why the first approach I'll recommend it. Okay. Go for it. Go for the SI units. You don't have to remember any of the coefficients. This is the thing. Yes. Now, an immediate question in relation to the seventh question. Okay. If ratio between Operating pressure is P1, P1 and P2 is 1:8. What is the ratio between VMD1 and VMD2? VMD1, VMD2 is the volume mean diameter. I already told you about this in the seventh question. Okay, inverse relation to the power 1 by 3 is there. Okay, so please do try to solve it. Okay, if you want, I will just revisit this slide. Okay, here the relationship I have already given you, just have to calculate d1 divided by d2 equal to p2 divided by p1 raised to power 1 by 3. That is the relationship. If it was nozzle diameter, that would be d1 over d2 into raised to power 1 by 3. Okay, because direct relationship is there. Here inverse relationship is there. Okay, try to note this particular formula, this one formula. Okay, and try to solve this question. Okay, this particular formula, you try to note it down. Okay, and then try to solve the question number 9. Okay, this, no, not this one. A 1:2. Okay, good. Sorry sir, C. Okay, no problem. C, good.
Option C should be
Okay, okay, I got
correct.
it.
2:1.
Okay, okay, C option, that is with from Pradeep. Okay, good. Varnika, I think please do revisit your calculation. Okay, the relationship I told you, VMD1 over VMD2 is given by P2 over P1 raised to power 1 by 3. That relationship I have told you. Okay, I think you committed some mistake. Please see your calculation. Yes, C would be the correct option. Definitely. Direct relationship I told you, VMD1 over VMD2, that is P2 by P1 raised to power 1 by 3. Okay, in the examination, please don't commit any mistake in this type of questions. These are easy questions. So directly the ratio has been given P2 over P1. P1 over P2 is given 1 by 8. So P2 over P1 would be 8 ratio 1. Okay, so keeping 8 ratio 1 or 8 upon 1 in the value or in the formula, 8 over 1 raised to power 1 by 3. 8 is 2 cube. Okay, 2 raised to power 3. So 2 raised to power 3 into 1 by 3 or 1 raised to power 1 by 3 is 1 only. Direct answer 2 ratio 1. Okay, please don't commit any mistake in the examination. These type of questions are very easy. Relationship formula already I have given you. Okay, try to remember it in the examination because it won't be given. Okay, yes. Last question for the day. The boom sprayer equipped with hollow cone nozzle is operating at a speed of 6 kilometers per hour and the nozzle spacing is 45 centimeter. If the application rate is 220 liters per hectare, then the flow rate for a hollow cone nozzle is given how many liters per minute or liters per hour. Okay, flow rate you have to calculate. Easy approach. Okay, see here, application rate has been given in liters per hectare. Okay, and to me flow rate is getting asked, flow rate is being asked in liters per minute. So liters per hectare, if I'll just multiply it with the speed, okay, in kilometers per hour, and then I'll multiply it by width, then I'll get the flow rate in liters per hour. Okay, that I can convert to liters per minute or liters per second, any unit which I want. Got the approach? Okay, I'll write it down. Okay, no problem. I'll help you, but you have to solve yourself. Okay. See here, this flow application rate has been given in liters per hectare. So I'll write it down. Okay. And I have been asked what is the flow rate in liters per minute. Okay. So liters per hectare, the application rate has been given, directly multiplying it by S and W. Speed has been given in kilometers per hour. Okay. I have to convert it in meters per hour. Okay. Then I have to multiply it by the width of coverage, that in meters. Okay. This particular approach I have to follow. This kilometer I have to erase. I have to go for meters. Okay. Then I will directly get my flow rate in which unit? Liter per hectare. Hectare also I have to convert. Hectare would be 10 is per 4 meter, 10 is per 4 meter square. Okay, that I also have to convert. Okay, unit conversion is important here. Okay, 10 is per 4 meter square. Meter square, both will get cancelled. Liter per hour, then I can convert in meter. Liter per second, liter per minute, any unit. Okay, please try to calculate. I'll give you enough time. Okay, all the things you have to multiply. That is the only thing. Liters per hectare, the coverage application rate has been given, multiplied by speed, multiplied by width. Okay, width of coverage. That is the thing. Use just same unit. Okay, you will get the answer in liters per hour. Then you can go for liters per minute, liters per second, whichever you want. Simple approach. Okay, Varnika is saying 60 liters per hour. Okay, very good. Others, please do try to calculate it. Okay, it's an important question from the examination point of view. Okay. 59.4, that is 60 would be correct option. Very good, Pradeep. Very good. Yes. Yes, let us move forward. Okay. Indeed, you both are correct. Okay. The correct flow rate would be 60 liters per hour only. Okay. See here, the application rate has been given. Okay, no problem. 45 centimeter nozzle spacing has been given. Then sprayer speed has been given. Then the nozzle flow rate directly. No need of any coefficients, nothing. Application rate multiplied by nozzle spacing multiplied by sprayer speed. I told you the formula. Okay. According to the units in this solution that has been given divided by 600. But you can go always for SI units. Okay. The approach I have told you. convert your sprayer speed in meters per hour. Okay, then nozzle spacing in meters, then liter per hectare in liter per meter square. Okay, multiply all of them, you will get the option as 60 liters per hour or 59.4, which has been calculated by your colleague Pradeep Kumar. Okay, okay, this marks the end of today's session. Okay, if you are having any doubts, then please do ask me. Okay, else, thank you for joining the session. Okay, thank you all. And please do join the session next week at the same time, 3 to 5. Okay, Saturday. Thank you all for joining. If you are having any doubts, then please do ask me. The session is open for you. Okay, else you can kindly leave. Okay, no problem.
Sir, what type of question asked in NPTEL exam?
Please do contact the NPTEL team. I think they are just going for objective type of questions. Please do confirm it. Okay. Please do contact the NPTEL team. You all must have been added to a Google group. Okay. In that Google group, you can always ask them. Otherwise, you can mail them. And what is the exact pattern? They will be telling you how much marks they would be telling you and what is the weightage of the assignment. These all the questions, basic questions are there. Okay. I don't have the exact knowledge. Okay. Which, what is the pattern as well as the distribution which they are going for in the current semester. Okay, please do ask them, they'll tell you. Okay, yes, according to my knowledge, that would be generally objective type, whichever the questions which I am solving. Okay, in front of you. Okay, as well as you are also solving along with me, that would be the only pattern. The examination is, I think, entirely objective. Okay, and you would be allowed to use a virtual calculator also. Okay, this entire thing you can confirm with the NPTEL team. Okay, yes.
Okay, sir.
Okay, thank you, Uday Kumar, for joining. Please do join the session next week at the same time. Thank you very much for joining the session.
Thank you, sir. Have a good day.
Okay, thank you so much. Have a good day.